Question 6. The number of Drosophila or fruit flies n in a colony after t days of observation is multiplied by n equals 30 times 2 to the power of 0.072 times t. Give whole number answers to the following. How many flies were present when the colony was initially observed? So if we're finding out when the colony was initially observed, again, that means we have to let t equal 0. If we let t equal 0, we have n equals 30 times 2 to the power of 0. 2 to the power of 0 is 1, which means we have 30 times 1, which is just 30 flies. Sorry, and I should have let that n be n0 because we're finding the initial amount. B. How many of the insects were present after 5 days? So we let t equal 5 into our formula. Put that straight into our calculator. And we find that we get 38.5. Now, the question did ask that we give our answers in whole numbers. The question is, do we round up or do we round down? And I would disagree with the book. The book rounds up. I would round down because I think that in order to get 39 flies, it would have to have slightly more than 5 days elapsing. So in other words, at the end of 5 days, we'd only have 38 whole flies. So I would actually round down there and say that that's 38 flies. Part C. How many days does it take the population number to double from its initial value? Well, we know that the initial amount our N0 we found earlier was 30 flies. So double would be 60 flies. So we put our N equals 60 into our formula. So that we have 60 equals 30 times 2 to the power of 0.072 t. And we can use solve to find that answer. If you round up to a whole number, the answer should be t equals 14 days. Part D, we're asked to sketch the graph of n versus t to show how the population changes. We should recognize that this is exponential growth. Because we have a formula in the form of a positive and a positive. So we should recognize that that should take the exponential growth shape. We do not need CAS to sketch it because there is there's no shifting of the graph up and down, so our asymptote is just going to be at n equals 0. We've also got 3 points on the graph that we found previously. So we've already found the point 0, 30 in part A. In part B, we found the point 5 and 38.5. And in part C, we found the point 13.9, 60. Notice I'm using the values before they are rounded to whole amounts. So if we put those 3 points onto a Cartesian plane, so we have the point 0, 30, the point 5, oops, and the point 13.9, 60. Then we can quickly see that that exponential growth shape and just draw a line straight through. Make sure with these graphs that you are labeling the axis not only with the variable but also with the description of what that variable measures, or the units. So we've got the number of flies and we've got time in days. So for the last part, E, after how many days will the population first exceed 100? So we're going to let, oops, what's going on there? We're going to let n equal 100 and find out what time has elapsed. So we're going to have 100 equals 30 times 2 to the 0.072 times t. Using solve, we'll find that t is equal to 24.12. Now the question said, back again, sorry, the question said, after how many days will the population first exceed 100? And we need to round that up, so it won't, you write it out like this. So for the population to exceed 100, more than 24 days would have to pass. So when we round it up, we've got to say that 25 days would need to pass.